So Technology Will Save Us is what we call ourselves a haberdashery for technology and education. What we mean by that is it's a place where you can go and get both the things that you want to learn how to make things with, but also the expertise and know-how to make that thing, specifically in the realms of technology. So the idea is that nowadays people are very interested in creating things and making things and being more creative rather than just consumptive, more productive rather than just consumptive. And especially in the realms of technology, where you're always being given a new fine and fancy product from one of our favorite product designing companies. Obviously Apple comes to mind, or Samsung even. So we wait for them to come up with this amazing product and give it to us, and then when there's something wrong with it, or it breaks, or whatever the case may be, we kind of lose interest in it and look to the next best thing. We see that as a real problem. We see there's a real opportunity for people to learn how to, A, what goes into making these things, and B, how they can then either repurpose them, fix them, make them their own in some really interesting way. And it's not just about modding things, it's about actually making from scratch. So Technology Will Save Us is actually an educational kit company. We create these educational products, these little kits which basically have a very specific educational agenda associated with each one. Everything from soldering a light to sound musical instrument. It's 15 electronic components, which a lot of people have never seen before they touch this kit. They put them all together in a circuit board, and the result is that they have this light to sound musical instrument. So the two lessons you learn there are, number one, you can learn to solder and understand how the soldering process unfolds, the correct solder methods, etc. But more importantly, how to make something with technology. It's quite a revolutionary moment for a lot of people, that all these disparate components, which are meaningless on their own, suddenly become so much more than the sum of their parts when they put together. That's a magical moment for people. Technology Will Save Us started, my partner in life and crime, Bethany, Kobe and I used to live in this area of East London called Hackney. In fact, we still do live in Hackney. And we had this really interesting creative community living around us. And in one of our big sort of skips, the big trash cans from the council, we found a laptop case, and we looked at the laptop case, and I tend to go through trash. Oh my goodness, that's the laptop case, there's nothing wrong with that. And I pick it up and realize there's something in it, thinking, oh, maybe they put books in there. Turns out there was a fully functional, fairly powerful laptop inside there, which somebody just obviously thought, well, that's gathering dust, I might as well just throw it away, because that was what they thought made sense to do with that dead piece of technology. It's not dead, it just could have been reused, given to somebody else. Anyway, that blew our mind. We could not believe that people would think it was okay to do that. And that created a bigger conversation about, why don't people understand technology in the way that we're starting to understand it? Why is it that we're not being taught the value of the components and the elements that are being built into this technology? We're just being taught to throw it away and buy the latest and greatest next one. So that conversation ended up with us realizing that there was just a gap in the world of education. High schools, middle schools, universities, there's this lack of sort of practical understanding of technology, because it's changing so fast they can't keep up. So we wanted to solve that problem by creating educational experiences for people that would help make them more responsible about the technology in their lives. So Technology Will Save Us, the core team, the two founders, Bethany comes from a sort of branding and innovation background, and her real interest has always been around sort of the social impact that businesses can have. My background is much more on the sort of creative technology side, basically building interactive sculptures, loads of electronics and programming, but really from a practical point of view and not so much from a theoretical understanding's point of view.
So you started as an artist?
Yeah, started as an artist. Yeah, in fact I was trained at Wits University in South Africa in Johannesburg as a fine artist, and then I moved to New York and studied at this amazing program called Interactive Telecommunications Program at NYU. Which is where I focused on physical computing, and ever since then I've been dabbling in electronics and tactile computing. Right now we're busy developing 3 new kits. We got a grant from Nesta, which is it's, I think, the National Endowment for Science, Technology and the Arts, to create 3 new kits specifically aimed at young people. And so our intentions are to, one of our kits right now that we're developing is a how to make your own video game kit, to be named correctly later. But in a nutshell, it's actually something that we're prototyping right here. It's going to be super simple. So it's actually more of a programming experience than it is an electronics experience, although the electronics are the vehicle to get to a point where you are ready to actually do the programming. So you need to go through some electronics so you can actually make the thing you want to from a gaming point of view. We launched our first mini retail space in September of 2011. And that was when we consider our official start.
How big are you? Like?
Well, now we're 6 people in the studio. We are, I guess, as bootstrapped as it gets, you know, very, very busy creating kits constantly, offering workshops with the same kit. So essentially, when we create a kit for the first time, we get to test it out on our audience. And that helps us to iterate the kit to make a new one immediately afterwards. Okay, that doesn't work. Let's quickly change that for the next time we do.
Principles in there.
Well, I mean, we kind of, it's almost like, you know, they talk about sprinting and all that wonderful scrummage in the world of startups and technology developments. Well, we do something kind of similar when it comes to our physical kits. We do a little sprint to create the product, which means we basically work really hard, really fast, put something into people's hands, learn what doesn't work.
Your MVP.
Yeah, exactly. Absolutely. They either love it or hate it. We learn from watching them work with it, make modifications. The thing we learned when we started teaching programming and electronics was that people who have an idea already when they come to the class, they often learn faster than the others because they know what they're aiming for. So they kind of like, oh, okay, I totally understand how that's going to help me with my project. So what we realize is we need to give people the excuse to learn how to program. Just wanting to learn programming isn't often enough to drive them to really pick it up. So we wanted to give people that excuse. And so what we decided to do was build the excuse. And there's something pretty fun about having 174 LEDs on your face. This is our prototyping version. You can see the little wires from programming.
And that kit is, how much does that retail for?
This one retails for £160. It's our most expensive kit. It's one of the reasons why we haven't actually gone into mass production with this thing, is because it's just quite expensive and therefore inaccessible. But what it's done for us is it's been a brilliant R&D platform. So what we've done is we've developed a really fantastic way of programming it. So the way that people would access this is they would, on the one hand, we have a little open source piece of software to help them take an animated GIF, a photograph, or a video and convert that to something this can play. You upload the resulting file, it's a little data file, to this little micro SD card. This is a little micro SD card reader right in the back. You plug it in, turn it on, and there's a little switch in here, in the top here, which actually controls the playback. You can switch through each animation, which is pretty cool. Exactly. There's also a microphone built in. So what happens is, so now that you've added some content, we've done something. Next level is to actually program it. So we've got a microphone built in. If you want to use the microphone, the only way you can do that is to fire up the programming environment, compile a file, upload that file to the micro SD card, and then when you plug it in, it will bootload it. It will load it into the microcontroller, and you'll see the results, which is a microphone responsive animation. But then once you've done that, hopefully you're ready to start building your own animations. So it's really a multi-step process. We don't see this as a one-hit wonder, but hopefully something that will grow. And now what we're doing is we're taking the technology that we've developed for this and using it for a new kit that's in development. It's a wave that's still brewing. I wouldn't say it's peaked yet, and it's not crashing, that's for sure. But it is building up significant pace at the moment. And Chris Anderson's comment on it being sort of the next industrial revolution is probably spot on, because the idea is, in the same way that desktop printers were, I mean, if you think about it, printing was something that was not accessible to people, and then at some point in fairly recent history, printers became accessible to people in their local offices and then in their homes. And that really changed the way desktop publishing worked. And now desktop publishing actually can start pushing into the world of desktop manufacturing. And there have been these things called Fab Labs that have been open since MIT started opening them about maybe not quite a decade ago, maybe 8 years ago. Those are really interesting. And then these hack labs have been popping up, and that's a really interesting phenomenon as well. They're all over the world. There's hundreds of them. And then these other little maker labs are sort of growing up as well, where people are just sort of co-working in a space where they may share a 3D printer, may share a CNC router, they may share the tools that will help them to manufacture things for themselves. So that's a really interesting thing. At the same time, you have these platforms like Kickstarter that connect people, buyers, with not existing products yet. As soon as they then say, you know what, I want that product too, when they have enough people, they actually manufacture the product in a way that only big companies could do that. So that's a really interesting change as well. So all these platforms are sort of slowly but surely building everybody up to this understanding that you don't have to wait for the big guys to figure it out. You can support little guys and help them to grow into these really interesting, innovative companies, which is fascinating. So from our point of view, technology will save us. We're very aware of the fact that there's a gap in people's knowledge around technology. Now, in the developing world, there's a resourcefulness around technology that you just don't see in the developed world, because resourcefulness is often the result of need, right? When you have a phone that breaks, it's expensive to replace, so what do? You fix it, or you find somebody who knows how to fix it, and there's an amazing sort of fixing culture in the developing world, which is something we would love to learn from. And at the same time, I'm sure there's an opportunity for that sort of culture to be brought into the developed world, because there's so much to learn from that for us.